Hello, in this video we are going to keep talking about doubling time and half-life, okay? But the catch this time is that we're just going to be given a chart, alright? So here's a chart right here, and we're going to assume that it comes from an exponential function, okay? In a previous video you've already seen that you really only need 2 points to determine the entire exponential function, okay? So that's why I've only put 2 values here. And the goal is, from this chart, find the doubling time or half-life, whatever is relevant for that chart. Because remember, doubling time is only relevant to exponential functions which grow, and half-life is only relevant to exponential functions which decay. So that's the first thing you're going to have to do, all right? You're going to have, so let me put there, step 0 is to identify if you should be solving for TD or you should be solving for TH. Okay? In this case, you can see that at t equals 1, you start at 9, but then you go down to 5 at t equals 3, so this is definitely decaying. So this is definitely going to be a half-life problem. Okay? And the next step is, well, remember what TH was equal to. The formula for TH goes like this: ln of a half divided by R. Whoa, that was easy. So I'm done, right? Because ln of a half divided by R is TH, and that's my answer. Well, yeah, that would be your answer if you actually knew what R was. But right now you don't, and at least looking at the chart, you probably can't eyeball it unless you know the procedure. But anyway, you need to know R. So step 1 will be to find R. And of course, once you found R, all you need to do is plug it into this formula for TH. So the final step, step 2, is going to be simply to use the formula. TH is equal to ln of a half divided by R. Alright, so it's basically 2 steps. The first step is really just an observation you have to make, where you look at the chart and you realize, oh, this is I can solve for a doubling time, or oh, I can solve for a half-life. You can't solve for both because exponential functions can't be both decaying and growing at the same time. All right, so let's move on to So let's move on to step 1. We're going to find R. Here we go, right here. Find R. Well, we know that when you plug 1 into the exponential function, you get 9. When you plug 3 into the exponential function, you get 5. Remember that an exponential function will take this, the exponential function will take this form, p0, which is the initial value, times e to the rt. Remember, r is the thing we don't know, okay? And p0 actually wasn't given to us, all right? P0 is when t equals 0. What you get when t equals 0. That wasn't given to us. So actually, as you'll see, it's not going to matter. But anyway, look what I'm going to do here. I'm going to divide p of 3 by p of 1. We know that that's equal to 5 over 9. Now, why am I going to do that? Because p of 3, well, if I plug that in, I get p of 0, e to the r times 3. And I divide by p0, e to the r times 1, so I won't even write that. I won't even write the 1. And look what happens. P0 cancels out. That's nice. So that's the reason why we don't need to know what the initial value is. But now here's another nice thing. When you take e to the r3 divided by e to the r, what happens? Same base, but you're dividing, so the exponents subtract. So you get e to the r times 3 minus 1. That's just equal to e to the r2. Okay? So you have this equals this, and they're equal to each other. When you solve for r, of course, how do you do that? You know by now, ln of both sides, then you divide by 2, so you get r is equal to ln of 5 over 9 divided by 2. And there is your r. When you plug that into your calculator, you'll actually get negative 0, well, let's wait a little bit for the computer to catch up to me here. equals negative 0.2939. Okay, so there you go. We have the R. What's the last step? Just plug it into this formula for the half-life. So look what we get. We'll get equals ln a half divided by negative 0.2939. That's going to be equal to, if you just plug that into your calculator, 2.3584. And you could put seconds if you want. There weren't units involved here. But the answer is 2.3584, which you should see in a moment. There it is. And that's the answer. Okay? Well, of course, one suggestion, well, of course, we found the half-life. You could do the doubling time just as easily, or in the same way. You just have to make sure that the chart actually allows that. So one thing you could try to do right after watching this video is to do the same exact problem, but to put P of 1 equals 5 and P of 3 equals 9. So try switching these two numbers right here, and then the exponential function would be growing, and you could find the doubling time. The time should be exactly the same, actually. So hopefully you can check that for yourself. And that's all.